Hello and welcome back to another tutorial. In this tutorial, we focus on understanding scope in Python. For us to have a better understanding of scope, we're going to build this up by scaffolding some other knowledge. So we're going to look at namespaces and name resolution, and that's going to give us an underpinning understanding in order for us to better understand scope in Python. Now, you already probably know what a variable is. So let's just set up a simple variable. So here we have an identifier. We can call this an identifier, and we can assign it a value. So n equals 1. Of course, we probably know this as a variable. So what's happening here, we can say that we have this identifier here, but essentially we've assigned a value to a identifier n. So in order for us to actually print out, for example, the number 1, we need to know what the identifier is to that object. So that's going to be n. So n gives us access, or maps across to this object, which is storing an integer, the number 1. So obviously when we print that out, that's going to print out number 1. So some general rules here. If we didn't define our variable and we asked to print out n, obviously what would happen now is we would receive a name error because n is not defined. So we could say that the process of determining the value that's associated with this identifier n is known as name resolution. So behind the scenes, Python is looking for this identifier behind the scenes so that it can associate that to the associated value. So in this case, n equals 1. So name resolution then is the process of Python determining what n is. So it looks behind the scenes for n, and hopefully that's then associated to some sort of value, and then we can print it out. So name resolution. So there needs to be some way of managing these identifiers, and that's where this concept of namespaces comes in. So we can say that a namespace manages all of these identifiers that are currently defined. So we can actually go ahead and vertically this. We can actually go ahead and utilize some built-in functions to actually see the current namespace. So let's go ahead and print, and we've got vars. So vars is going to give us it's going to return a dictionary of all the current names or identifier that's currently stored in this namespace. So let's go ahead and run this, and you can see at the bottom here we've got X and Y. So here we've created our identifier and assigned it to two values here, X to the value 1, Y to the value 2. And you can see here that when we print out this namespace here, we can see that it returns a whole heap of other names and values, but in addition to that, you can also see the current variables or identifiers and values that are currently being stored in this namespace. If you just wanted to see the actual keys, because you can see this is returning a dictionary. If we wanted just to see the keys, we've got dir, and that would just return the keys, so X and Y. So in order for Python to go through that process or run through name resolution, the actual name needs to be within this namespace. So if X or Y hasn't been declared, and we then try and print it off, X isn't going to be within this namespace. So therefore Python cannot find the associated value to X, for example. So in this case, hopefully I'm making this too simple. So error name, X is not defined. So if we go ahead now and print out the vars, if we do that, we can now see, for example, X is still there. So let's just get rid of that. You can see that X actually now isn't in the namespace at all here. So Python cannot find X, therefore it can't print it out. So let's move on to scope then. So what exactly is a scope? Well, let's just take this identifier here and value. Whenever we assign this variable has automatically been assigned to the global scope in this case. So this global scope, this idea of a scope, each distinct scope, and there are 4 of them which we discuss in Python, is represented using an abstraction known as what we know as the namespace. So what we're saying here is that we have a scope, so that scope is stored as a namespace. So let's look at the namespace like this. So let's go back and print our namespace here. So remember, that's going to print off. That's going to print off all the identifiers that's currently being stored in this namespace. So we can say that this namespace is all part of the global scope, which means that anything in my program that's developed in this space will have access to this global scope, all of these identifiers here. So if I wanted to access in my global scope here, X, because that is in the global scope, I just need to type in X, and through name resolution, Python will look at this namespace, which is all part of the global scope in this case, and then it will obviously print out 1. So like I said, there are 4 scopes we can talk about. Here, we're talking about the global scope, globally accessed variables here. So the next scope we can talk about is a local scope. So let's just, for example, create a new function and we'll go ahead and we'll run the same command. We'll say print and then vars again. So we'll have a look and see if we can access the namespace again inside of this variable. So we'll just run this variable and we'll have a look. So notice now what gets returned is absolutely nothing. So inside of this function here, what we have is something called a local scope. And you can see that this local scope is unique to this function. And you can see it doesn't access the global scope. It's an empty dictionary that gets returned. So this type of concept allows me to define similar variables or similar identifiers. So here I've got a variable X, and inside of here I can also have variable X. And these are in different scopes now. X here is in the global scope and X here is in the local scope. So here I can type and I can print out X here. So this would print, clear that. This would print number 2. So here I'm referring to X. So Python looks at the local scope first inside of this function and returns X. However, if I were to remove this, what will happen here is that Python will look at this local scope first. And then because scopes are hierarchical, Python will then look at the namespace or the scope here and find X here. And of course, X has been defined in this global scope. Therefore, we're still going to print X. And now we print number 1. So it's important to remember here that we can't go from a global scope and look into a local scope, but we can go the other way. So if we're in a local scope, we can go up into the global scope. So just an example of that, let's just pretend we have y equals 2 here in this local scope, and we try then just to run the function. Let's just try ahead and print y. So because this code here is in the global scope, this is only going to look for the global scope. It's not going to go into the local scope. So therefore you get the message name error, name y is not defined. So don't forget we can access the scope inside of this local area here. So if I did that, you can see that in this local scope here in this function, we have this identifier y, and it's associated with the object number 2. So I did mention we can think of 4 different scopes. So local, so we've seen local, utilizing that within a function. We have enclosing, global, and built-in. So we've seen global and local. So let's just go through the process and understand a little bit about enclosing and this idea of built-in. But what we see here is a hierarchy of scopes which Python runs through from the top to bottom to look for namespaces and looks for the associated identifiers that the program is looking for. So for example, if we were in local and we asked to see the variable n and it wasn't in the local scope, it will look for the enclosing scope. And then if it's not in there, it will then go to the global scope. If it can't find it in there, it will then look for the built-in. So Python is going to look for all these different scopes for that particular name, that identifier in this kind of scope resolution or name resolution process. So let's just put that in action. So this idea of a enclosing. So let's go ahead and create a function in a function. So here, zoom out a little bit. So here we have a function within a function. So we just need to call this second function. We'll call this function 2. So we'll say function 1, function 2. So what's happening here, we call the function 1, print off this function's local scope, and then we go ahead and run this second function here, and then we print off the local scope of this function here. So what we end up with is, at the moment, is 2 empty scopes, because currently we haven't defined anything within this scope, this local scope, or this local scope here. So let's go ahead and say y equals 1 here in this function. Okay, so now what we have is, actually, let's put it right here. So now what we have in the first scope, in this local scope, in this function 1, is we have in the scope y1. Okay, so we've defined the y, we created this variable here, and we've got this identifiable number. So let's go ahead and inside of this function here, let's just go ahead and print y. Okay, so y. Okay, so if I go ahead and print that, you can see it is printing 1. So what's happening here through this idea of name resolution, namespaces and scope? First of all, Python is looking in this scope here, this local scope to this function, looking for the y, trying to associate y. And when it can't find y within this scope, this local scope, it then goes to the second scope. So this is what we're called the enclosing scope. Okay, so this function is a sub-function of this function here. So what's happening here, we look for y in this local, and then we look for the enclosing scope, which is this function here. And then if Python doesn't find y there, it's then going to look here. So if I change this to y and remove this, we can now see the kind of the whole order here. There we go. So y is still being found here, although this is in its own local scope. It then first of all looks in the local scope. Python will then look in this enclosing scope, and then it will look in the global scope, and then it's found it in the global scope. So hopefully that gives you a general idea of what the local, enclosure and global scope is, but what's the built-in scope? Well, Python built-ins, maybe you've used, for example, some of the different functions, for example, length, to get the length maybe of a list. So these are ideas of kind of built-in functions that Python has that we can access, and we access them through the name, in this case len. It could be, for example, iter or dir or bin or any, all, for example. So these are all built-ins, and they have names, and we can access them through their names. And this needs to be stored somewhere. So if we print vars again, you can see that in this list we do have built-ins, and that's connected to this module built-ins. And from there we can access all of these different built-in commands. There are many ways for us to actually see them. We can go ahead and import the built-ins, and then let's just say print dir built-ins. Let's give this a go, and there we go. So there's a list of all of the built-ins. So essentially what we're trying to do here, what this is telling us in actual fact, is that we shouldn't assign any variables in our application with these names. Otherwise that could cause cause issues. Take this simple example. Here we have a list, and I'm just going to use length or len. This is one of the built-ins to actually measure the length. So this should return 4. There we go. So what if I, for example, accidentally create a new function called, a new variable called len equals 10? What will happen then? Well, that's where we start to break things. So it's important to understand and to use good variables or follow best practices when building your variables so that you don't accidentally use one of the keywords or identifiers to the Python built-ins. So now in this example, we can see that if we wanted to use the len here function to get the length of this needs to be, this name needs to be resolved. So it's going to look first of all in the local scope for len. If it can't find it there, it's going to look in the enclosing scope, this function here, because we have an embedded function. And if it can't find it in there, it's going to look at the global scope. And then last of all, it will then look at the built-ins. And of course, it will find len in the built-ins. So this should work absolutely fine. So one thing to be careful of here, if we just get rid of this inner function, let's go ahead and define x equals 1. So we'll go ahead and say x equals, now remember we can use x here as well because this is the local and this is the global scope, but we're going to say x equals x plus 1. Okay, so let's go ahead and just let's print that. So when we run this function, we're going to print that there. And actually, we'll return it. Sorry, let's return x. Apologies. Okay, and then we'll just go ahead and print it here. Okay, so we're going to run this function and print out the return. So here we've got x, which is going to be a locally assigned, and that's going to equal x plus 1. Now the problem with something like this is that x isn't bound to anything, so it can't find x at all. Yes, we've kind of created a new variable. We're going to create a new variable, but x hasn't been defined in this scope, so therefore we can't perform this type of operation. And that just leads me to this idea of, which you shouldn't really do, is that we've got this keyword global, so we can say global x. And now because of that, we now have this x defined. So therefore something like this would be able to work. And that returns 2. So x referring to this 1 here. So 1 plus 1 equals 2. So as a little bonus really, at this point, I was going to mention this idea of first-class objects. So just kind of introducing this idea of first-class objects, a type of terminology in programming. First-class objects can be described as instances of a type that can be assigned to an identifier or passed as a parameter or maybe just returned by a function. So in Python, functions and classes are all treated as first-class objects. So we can do some interesting things here. So you're probably already aware of the print function, right? So that's going to print something to, in this case, the terminal. So what we can do with this idea of first-class objects, being that this print function is considered a first-class object, is that we can, for example, make an alias to it. So take this, for example, x equals print. So this is this idea again of global namespace here. Sorry, the built-in namespace. We are kind of utilizing that at this point, if you like, to kind of call this print. So what we've done here is we've made an alias to print, and we stored it with this identifier x. So x really is just storing the print function at this point. So what we can say here is x, and then we can just pass in something. So let's say classic hello world. And then we can print that off, and believe it or not, that just prints it off. So this is a way of making an alias. So first-class objects, it's worth maybe reading more into. It's quite interesting, and this kind of relates to this idea of namespaces and scopes, etc. So we've made essentially an alias here to the print function, and we've used it here to print off, in this case, hello world. Okay, so that was a little bit of rambling. Hopefully I didn't ramble on too much there or embellish too much. And I try to make it, I try to repeat myself to hopefully make it easy for you to understand. It's always kind of an impossible task. Having taught students, you always tend to forget that some things that you may find really easy to understand in fact is quite difficult, and sometimes you really kind of need to just bring that down a few levels to help and support that learning process. So it's always impossible in that respects to build a tutorial that's kind of catered for everyone, because everyone's going to have different levels and capabilities and abilities and previous knowledge. So I do hope that was useful to you, and yeah, I hope to see you in the next tutorial. If you have any ideas or suggestions for tutorials, please let me know in the comments. And yes, I hope to see you in the next tutorial.